Okay, so thanks very much. It's really an honor to be here and to attend this conference in the wonderful city. So I would like to talk about some work done in collaboration with Filippo Passerini, who's sitting there, and Fabrizio Neri, who's a student at Sari. So let me start with some motivation. So in recent years, we have seen many exact results have been obtained with the method of supersymmetric localization. And in this conference, we have seen several beautiful examples of the application of this technique in the talks of Seok and Sanjay. So the idea, which I don't need to repeat, but it's basically that the path integral of the theory, oops, sorry. Where is the pointer? Ah, okay, sorry. The path integral can be reduced to an integration over a finite set if one adds to the action a q-exact term and is chosen in a smart way so that when this term is let to dominate over the action, one can use the saddle point method. So, of course, having exact results for partition function is very useful, and the application have been basically of two types. So one can, of course, try to use this exact result to explore holography, and we have seen really impressive tests of holographic duals. Another possibility instead is somehow to stare at these exact results and try to find connections with other exactly solvable models, such as conformal field theories and topological quantum field theories. So this is more like in the spirit of what I will try to describe today. So, of course, the precedent is the celebrated AGT correspondence that teaches how to relate partition function obtained by Peston of n equal to theory on the four spheres to correlation function in Liouville conformal field theory. So basically the idea is that when the partition function takes a very suggestive form of an integration over a Coulomb branch, and then you have basically the contribution of 4D instantons coming from the north and the south pole of the four spheres, and this is identified with a correlation function in Liouville with n primaries. So an important ingredient besides this identification is that the CFT modular invariance with descent by requiring associativity of the operator algebra is mapped into the generalized S-duality of the n equal to theory. Now, an early extension of this correspondence was the inclusion of certain important codimension 2 defects in the theory, which were named simple surface operators, but were known long before, which were argued in this context to be correlated to degenerate primaries. Now, this part of the correspondence has been, in a sense, completed very recently thanks to another localization computation, this time on the 2-sphere, which can be thought as where your codimension 2 defect in S4 lives. And it has been argued that the super QAD on the 2 spheres, which in the Higgs branch localization takes a factorized form in terms of vortices, this time associated to the 2 hemispheres of the 2 spheres, is captured by a correlation function in Liouville with the insertion of 3 primaries and 1 degenerate fields. And in this case, the crossing symmetry is related of the CFT, which is again the associativity of the operator algebra, is realized by the flop symmetry of the gauge theory. So basically, what I would like to take out of this slide is that, of course, that one can think of this correspondence as coming from M5 brane compactification, but I would like to take a more pragmatic viewpoint, which is the following, that here we are basically identifying instantons with conformal blocks, which are dictated by the relevant symmetry, which is Virasoro symmetry in this game, and we are requiring basically that modular invariance is realized as S-duality. But now these two ingredients basically are the two ingredients that allow to solve, if you want, Liouville theory by the method of the Bootstrap that we heard in this conference several times. So somehow a pragmatic way to express this is that the gauge theory and the conformal field theory are equal because they are somehow constrained by the same symmetry. Now this is the kind of a viewpoint that I would like to try to show that today can be somehow extended to higher dimension, and that a similar story holds in 3D and 5D. So we'll try to convince you that 3D partition function have some structure that recalls the generic correlation function in what I'm here calling q-CFT, but I will be more precise later by what I mean by q-CFT, while 5D partition functions are in the same spirit related to non-degenerate correlators in this q-CFT. Okay. So the starting point, or another motivation for doing this, is some work that I've been doing the past year, and also in collaboration with Chris Bean and Tudor Di Mofte, but also other groups have been generalizing, extending this, this observation, which is that partition functions of n=2 theory on the squash tree sphere that we heard today, and also the product of S2 times S1, can in fact be expressed in terms of somehow more fundamental object that we call holomorphic blocks. So this was basically a very experimental observation that comes from the brute force evaluation of the integrals, but somehow in certain cases it was predicted that this partition function should have this property. Now, basically the fact that they are expressed in terms of these blocks that are the same for the two theories is somehow resonating, even though it's not a trivial consequence of the fact that these two spaces are in fact geometrically obtained by gluing solid tori. So I will just use as an abbreviation to indicate partition function on the tree sphere, I will use Z sub S, meaning that this, to remind us that this comes from a manifold that is obtained gluing with the S element solid tori, and S sub E identity, the manifold, the partition function on S2 times S1. So together with Tudor and Chris, we proved several properties for these blocks, but today I want to just focus on two of them, which are the first one, which these blocks somehow provide a complete basis of solution to certain difference equations, and the other one that they have very non-trivial transformation properties under symmetries of the partition function. So on the basis of these two properties, I will try to argue that there is some sort of QCFT structure. Okay. So this is the plan of the talk. So the first part will be somehow trying to get to the block factorized form of the 3D partition function in a couple of examples. Then I will try to define what I mean by these QCFT correlation functions. And then I will try to relate 3D and 5D partition function to these correlators. Okay, so the partition function on the ellipsoid that was introduced short ago of n=2 theories, I'm considering here just a QED with some chirals and anti-chirals, was computed by this gentleman, and it takes the form of an integration over the Coulomb branch of a classic and one loop part, which is expressed in terms of these double sign functions. Here, just a comment that will be useful later is the following, that there is a symmetry in this integrand which exchange the sign of the phi parameter, and then I call flop symmetry, and it's a symmetry if it is accompanied by some exchanging of the masses. This is just a trivial symmetry of the integrand. Now, with some just patience, one can just evaluate, if you want, this integral and put it in this form, where we have the contribution of the classic and one loop part evaluated on supersymmetric vacuum of the effective theory that lives on the solid torus, which is a 2,2 theory. And then you have contribution of vortices, which are expressed in terms of Q-deform hypergeometric series. So these are vortices that lives on the hemisphere times S1. So notice that the parameter Z, which is the important parameter in this hypergeometric, is related to the Fi parameter. Now, these vortices appear in a square, which as I explained before, I call S pairing, and by that I mean that these exponentiated variables, they appear with B and 1 over B flipped. Okay, it's possible to furthermore completely factorize the partition function, also these two classic and one loop part, and put it in this sort of holomorphic block form, but for today, this form will be enough. Okay, so the same story can be done for the other space, which is S2 times S1, and in this case, n=2 theories were computed by several people. This is the form that one obtains studying the U1 theory with an F flavor for which I turn on these fugacities. This is the expression that comes from the Coulomb branch localization, so-called. So also in this case, there is this symmetry that exchange, that flips the sign of the phi parameter. Now, also here, one can basically evaluate explicitly the integrand and put the integral and put it in the factorized form, which is written here. So it's very similar to what I had before. So we have, again, classical part evaluated on the supersymmetric vacua, and then you have the contribution of vortices, which are exactly the same that we had before. So again, they are Q hypergeometric with the parameter Z related to the phi parameter. But the pairing this time is basically doing a complex conjugation on the variables that enter. Okay. So here an observation, which is important, which is this flop symmetry that I observe is a trivial symmetry of the integrand in the Coulomb branch. When I regard it in the Higgs branch, is in fact telling us some non-trivial relation between this block factorized form in these two phases. This is because these two phases are related to the flip of the sign of the phi parameter that enters as the parameter Z in the pair geometry. So it involves some analytic continuation. Now, this form of this partition function is somehow evocative of a 2D CFT correlation function where I'm somehow comparing the result in the two channels. So the idea is that somehow one would like to relate the flop symmetry, also in this case, to some crossing symmetry, and then the fact that our Q-deform hypers play the role of chiral blocks suggests us that the relevant symmetry here could be a Q-deformation of Varasoro. Of course, this guess is somehow supported by the fact that there was lots of work in the so-called 5D version of the AGT correspondence, where many authors checked that the 5D version of the instanton partition function is captured by Q-Varasoro chiral blocks. So just a word, what is Q-deform Varasoro algebra? So this was studied a lot in the past as a two-parameter algebra, and these are the generator that have this sort of scary commutation relation. But it's nice that if one relates the parameters in this way and send Q to 1, one reduces to the familiar Varasoro algebra. Now, the important information that I would like to take out from this slide is that also in this case, when one considered blocks with some degenerate primary, these blocks are annihilated by some difference equation. So this will be what will be my main ingredient, because what I'm trying to do now will be to construct correlation function with this symmetry. So the idea is to use, of course, the conformal bootstrap approach. So this method was proposed by Belavin, Polyakov, and Zamolodchikov, and used also in the context of the Liouville theory by Teschner to determine three-point functions, without using at all the Lagrangian, which I have no idea what it is, but just the symmetry in the game, which are the QT Varasoro algebra and this crossing symmetry. So I'm focusing on a 4-point correlation function with a degenerate states at level 2. So I know that in this case, this correlation function will be annihilated by a Q hypergeometric operator. So in general, I can look for solutions which are the form of a bilinear combination of solution of this operator. Right. So the solution around 0 are given in terms of Q-deform hypergeometric with some theta in front, but this solution has the property that when we remove the deformation, this becomes the familiar S-channel solution of hypergeometric solution around 0. So with that, I can construct my correlator as a bilinear combination with coefficient Kij's, which I take diagonal in analogy with the deformed case, and with coefficient related to the three-point functions that one would associate to the this type of diagram that I'm trying to compute. So at the moment, I'm not making any assumption about the way I'm pairing the two sectors of the theory, so I'm leaving generic for a moment. Now, I can do the same story in the U-channel and look at the result at the basis of solution in the around infinity, construct my bilinear combination, again with coefficient related to three-point functions. And at this point, I impose that crossing symmetry holds, so I compare the result in the two channels, and I can, in fact, analytically continue a solution from the S channel to the U channel by means of the analytic continuation matrices, and then I get an equation for these coefficients Kij. So this is the way I can extract three-point function just using symmetries. Of course, at this point, I should say what is this tilde, or better, what I mean by this pairing. So at this point, I should specify this. And to do that, I'm going to take somehow inspiration from the 3D gauge theory result that I presented earlier on. So the first thing that I'm doing is try to solve the Bootstrap equation, making the assumption that this pairing is, in fact, the identity pairing that I found when studying S2 times S1. So this means that I should just do the complex conjugation variable x and just invert q. Okay, it can be shown that you can solve this equation in terms of a three-point function which takes this form, which is very similar to the Dodds formula, in fact, and it indeed contains this function upsilon beta, which is, if you want, the obvious way to Q the form Dodds. So now I can make the first check that is basically consistency, that the partition function of U1 theory with two flavors on S2 times S1 is captured by a 4-point correlation function with one degenerate with identity pairing 4-point functions. And this is in formulas what I just said. And there is some dictionary. In particular, of course, the Z of the CFT, which is related to the Fi parameter, is mapped to the the Z of the gauge theory, which is related to the phi parameter, is mapped to the cross ratio in the CFT. External momenta are related to the fugacities, and then we have that the S1 circle enters in the parameter S1 radius, circumference enters in the parameter Q, and B0 is moment of the degenerate. So, of course, in the limit where we send B0 to 0, this is somehow the limit in which the Qt Virasoro algebra reduces to Virasoro. So on the CFT side, we recover just the degenerate Liouville correlator. And on the gauge theory side, we just go back to the two partition functions. So we are consistent with the claim of these people. Now, I can try to do the same story looking at another possible pairing that is suggested from the gauge theory, which is this S pairing, which I'm parameterizing this time with this parameter omega 1 and 2, and I mean that tilde means exchange omega 1 and omega 2. Now, if you try to solve the Bootstrap equation with this definition of the pairing, we found that a solution is provided by this three-point function, which is the same form as before, but changing the special function, and I have this triple sign appearing. I have a third parameter here, and I will relate it on the moment because they are not all independent. Okay, so the statement here is that the partition function on the squash tree sphere of U1 theory with two flavor is captured by a 4-point correlation function with one degenerate, an S pairing three-point function. So that's in formula. There is a dictionary also in this case, and which goes as follows. So you can relate one of the two parameter omega 1 and 2 to the squashing parameter of the tree sphere, and then the third one would be what plays the role of the moment of the degenerate. So, in fact, I have possibility of permuting the omegas, and this will be clear in a moment because my goal is to regard this tree sphere as one of the big deformed tree sphere inside S5. So these omegas will be in the end the squashing parameter of the phi sphere. So also in this case, as it was crucial, in the construction, the gauge theory flop symmetry is mapped into the crossing symmetry of the correlator. Okay, what I've been doing so far has been basically to look at 3D gauge theory partition function and to argue that they somehow are also expressed in terms of this QCFT degenerate correlator. Now, the natural thing to do is try to look at non-degenerate correlators. So, for example, I can look at a 4-point correlation function, and I can wonder if this corresponds to something on the gauge theory side. Now, again, the analogy of the AGT case where somehow the codimension 2 defect theory is capturing the degenerate sector of a 4D theory suggests to look for a correspondence with some 5D theory. So what I'm going to do now is to introduce two 5D theories which should be related to this type of correlation function. So the first theory that I'm discussing is the partition function on S4 times S1, which computes a superconformal index, and this has been computed by authors that are almost all in the audience, I think. So it involves the form of the Coulomb branch localization is quite similar to the result on of Pesson on the fourth sphere. You have one loop contribution, and then instantons, this time are 5D instantons, which comes from the contribution from the north and south poles. And then we have the one loop contribution, which we rewrote in terms of the upsilon beta function that I defined earlier on. So at this point, I can make some proposal that this partition function on S4 times S1 seems to be captured by correlation function where the underlying symmetry is given by two copies by the form Varezaro algebra, and I need to use identity pairing 3-point functions. So that's the 4-point correlation function, and then I need to do the check. So the first check that I'm doing is that the instanton sector is related to conformal blocks. And this, in fact, I don't need to do, because it has been done by several authors, again, in the context of 5D AGT correspondence. So this is known, that 5D instantons corresponds to chiral blocks in Qt Varezoro. So what I just need to do is to check that the one loop part is related to 3-point functions. So I take the contribution of a vector and 4 hypers, because I'm focusing on this particular theory, and that should correspond to the 3-point function factor associated to this diagram. Okay, so, and this can be checked, and here is the dictionary that relates the masses, the flavor fugacities of the S4 times S1 theory to the external momentum. Comment here is that we use the 3-point function that we got studying S2 times S1 because that's the relevant codimension to defect. And I think that the role of this type of defect was also highlighted by Iqbal and Waf. Okay, so the second theory that I would like to consider instead is the partition function on the phi sphere, and here I don't need to do much work because yesterday we had a wonderful talk by Seo Kim who explained everything about it, even though today I'm using more the language of Lokar Waffa, who also obtained the same result. So that's the partition function, which is given on this space, which is the squash S5. We have a classic and one loop part, and then as you remember from yesterday, we had 3 contributions for 5D instantons coming from 3 contributions of 5D instantons, and importantly, the equivariant parameters for these 3 sectors are related to the squashing parameter of the 5D sphere. Okay, so the one loop contribution, not surprisingly, is written in terms of triple sign functions, also in this case. So at this point, I can somehow try to see whether the S5 partition function is captured by some non-degenerate correlator where the underlying symmetry contains 3 copies of Qt Varezoro, and the 3-point function to use is this S-pairing 3-point function. So again, I take this example, which is the SU2 theory with 4 flavors, and I try to see whether this corresponds to this 4-point correlation function. Okay, so again, the check at the level of instanton I got for free by these people, and I just need to check that the one loop vector and one loop and the contribution of the 4 hypers and one loop is captured by the 3-point functions that I should associate to this diagram, and that works with some very natural dictionary. So once again, I will stress that I'm using the 3-point function that I got studying the squash 3 sphere because that's the codimension to defect inside the squash S5. Okay, so I have just some check to mention that if I use the language of the sort of the q-CFT and to study the phi sphere partition function, I can do the following experiment. I can take one of the external momenta, which correspond to linear combination of the masses for this SU2 theory with 4 flavor, and decide that it takes this special value, which in the CFT language is associated to the degenerate momenta. And then I discovered that the partition function on the S5 collapses to the partition function on the 3 sphere. So this mechanism is very similar to what happens in Liouville when you study a 4-point correlation function with all primaries, and then you analytically continue the value of one of the primaries to be degenerate. Basically, you have that the one loop part here, which in the CFT is due to 3-point function, has many zeros and some poles, so that the integration is in fact pinched to take values only from 2 points. So then one evaluates the residue of the one loop and classic part at these points. One finds the one loop and classic parts of the squash tree sphere. So it gets the 3D result. And interestingly, the instantons have a very nice pattern such that two of them, they collapse to vortices, and one just becomes completely trivial. And this is also true for other permutation of the omegas. I would like to comment that this fact that the partition function of special values of the fugacities becomes simple and relates to a codimension 2 defect was also found on S3 times S1 in a beautiful paper by Gayotto, Rastelli, and Razamat, where they somehow noticed that if you take some special values of the fugacities in this index and you go to special values, then this satisfies some difference equation, and it allows to bootstrap the index also in that case. Now, another comment is that since we see that for special values of the external momenta, our S5 partition function becomes the S3 partition function that has some crossing symmetry, which is related to flop symmetry of the gauge theory. So it's natural to ask whether there is crossing symmetry also at the 5D level, and if this has any interesting gauge theory meaning. Okay, so in conclusion, I argue that there is some hint of QCFT-like structures in 5D and 3D partition functions. And of course, it's interesting to study if there is some modular invariance also in the 5D non-degenerate case. One can try also to construct other correlators starting from other geometries that would come with other sort of pairings. And even if this correspondence needs much work, one can hope that, for example, one can use the language of QCFT, for example, to study certain gauge theory of observable, for example, using the language of the Verlinde loop operator that has proved to be very useful for the gauge theory case to study loop operators for the gauge theories. That's it. Thank you.
Okay, questions? Nadi?
Two questions about symmetries. One is, what is the flat space version of your flop? Is this charge conjugation?
Flop?
You had this flop symmetry. So what is the flat space version of that? Is that charge conjugation?
No. So for me, flop symmetry is flipping the sign of the phi parameter because I'm thinking in the language of the 2,2D sigma models, because this seems to be the relevant effective theories of my 3D theory in the semi-classical limit. So I'm just using this name to denote the theory in two phases where I'm changing the sign of the phi.
Is it the symmetry of the flat space two-dimensional problem?
In 2 dimensions, I think. In 3 dimensions, I don't think, because I'm studying the theory on S3, which is not the same as the one in the flat space. So it's a symmetry of partition functions, of S3 partition function. I don't know if...
And the second question is about your U1 with two flavors. This symmetry enjoys a rich spectrum of mirror theory.
It's true, yes.
And does that appear in your analysis?
Right. That's certainly true. I think I've chosen some other, to look at some other symmetries, but of course, probably also the symmetry is relevant. I'm just looking at this symmetry, but indeed, there is, of course, the self-mirror symmetry, which is, it might be also relevant here.
Sergey?
I also have two questions. Can the hypergeometric difference operator in the QT Virasoro be traced to word identity for line operators?
Can
it be traced to word identity for line operators?
I think so. It's your paper, so
Well,
no,
sorry, it wasn't obvious.
No, I mean, okay, sorry. So the point is that the fact that blocks satisfy, so the hypergeometric equation that I'm observing here are basically an example of the fact that these blocks that we are looking at are annihilated by the difference equation that are precisely the word identity that you discuss in your paper that possibly comes from studying Leibniz operator in 4D colliding at the 3D theory, which I regard as a boundary. So that, I think, is a special case.
Well, I thought you have an additional parameter. That's why I got confused.
Right, because so that in fact, thanks for the good question, because the second parameter is visible in 5D. In 3D, in fact, for this super QED theory, I see just one of the parameters.
Right, that's why I think what you're doing is extension, and I don't think we had it in that paper. Anyway, the second question is about proving the relation between instant-on partition functions. On S4, for instance, one can try to prove AGT correspondence by realizing Virasoro action in cohomology of moduli spaces of instantons. So since you looked at this, it's natural to think about proof of the 5D version by realizing QT Virasoro action in K-theory of moduli spaces of instantons. Do you know if anybody looked at it?
No, I might have read a sentence in the Maulik and Okunkov papers, I think, that it should be possible, but you are perfectly right in it.
Igor?
Yes, about this correspondence between 3D QED with two flavors and 2D CFT. Does it work for arbitrary R-charge assignment for the flavors?
Right, yeah.
That's
so,
a parameter in the correspondence?
So I must say that, yeah, it's a good question. So I didn't explore this much.
Is there a maximization that you need to do, or it's just a parameter?
I haven't looked it up. So it would be natural to do many things, for example, to look at, I don't know, quiver theories to see if they, for example, corresponds to more insertion of more degenerates in the correlators and other things. And probably one should also ask what it means to give other R-charge assignment, but I haven't looked it up.
Because I know with one flavor you know the value of the R-charge through mirror symmetry. With two flavors we actually determined it numerically, it's some number. So I was wondering if you knew what this number is.
No, I don't know, but it's very interesting comment. Yeah.
Okay, thank you.
I don't know.
So when you write down those Q-deform correlator, there are some condition. It's like you have a degenerate operator insertion.
Right.
Is there some clear cut? Then there's that point that you can actually distinguish the 5D partition function, 3D partition function. So is this correspond to some kind of decoupling limit that you kind of restrict all the kind of instanton degree of freedom on the surface operator in a corresponding finite gauge theory? Is it
yeah. I mean, this is a
see?
very simple-minded extension of what was done in the AGT setup to look at surface operators precisely. So it was somehow trying to decouple the bulk theory from the somehow 2D theory, which it means that if you start from a generic correlator with some primaries and some degenerate, then you basically decouple everything and you are left just with 3 primaries and arbitrary numbers of degenerate. That's just capture the sort of defect theory. I am decoupling away the bulk theory. So it's.
And does your approach, as far as I know, like the q-deform CFT, there's actually very little known about the actual form of a correlation function. So does your approach kind of somehow give some kind of prediction and related different class of q-deform CFTs?
Right. In fact, yeah. I mean, in fact, I'm using this name QCFT, but perhaps it's just. I mean, I'm just meant that I'm trying to construct correlator with underlying QT Virasoro symmetry, which, as far as I understand, they were not considered before, and we just use this axiomatic method trying to define some consistent pairing of blocks. But yes. I don't know exactly if this has been studied from other viewpoint.
Okay. Okay, so let's thank Sara again.